So first question, is this like separable?
Yes.
Yep, it is, right? Because even though it's written as a division, typically it's written as a product, right? You could just have 1 over y squared as one of the functions, right? So Callum, what was our second step that we always have to do as long as if we've identified it as separable? Because keep in mind, they're not always going to be separable. I think the ones in this course that they give you should always be, at least. But after that, Callum, what's our next step? Grouping, right? Because you want to be able to solve, which means you'll want to be having y is equal to something. That's the takeaway from this, right? So if I have over here, we take this and we try and group the x's and dx's and y's and dy's. So I'm going to get here, what does it look like to you? It looks like dy or y squared dy will equal to 2x dx, which is quite nice because we get some nice looking functions to integrate. Kyle, do you want to do that for me?
Y cubed on 3.
Yep, y cubed on 3.
Equals to
X squared, yeah, not too bad, right? And then we have your constant of integration. And remember, we typically want y as a subject here, right? So I'm going to, let's multiply both sides by 3. And this is what I'm talking about with like the c value. Like, again, if you want, you can do plus 3c, or you can change whatever the constant is, whatever you prefer, right? I'll just leave it like that for now. And then, sorry? I'm less okay, and this is when you're talking about being marked down, right? I'm less okay with you just leaving it like that. Is that what you're asking? Yeah. Yeah. Again, even if you mark down on something like this, like they've definitely got better things to mark you down on. But if they want to take something else, like if they want to, you don't want to give the mark any kind of chance to take stuff away. So I'm going to leave it like that. I would do one of the following. I'll do 3c, or if you want to, you can call this c1, c2, right? Whichever one you prefer, right? I'd like to see one of those two. Again, and then we just need y as the subject, so cube root of both sides for that one. So, and I'm going to leave that as k. All right, so that's part A, solving D. Part B, find a solution curve. Again, we are going to use these initial conditions, and I was trying to make some numbers that look quite nice. Don't think I succeeded, we'll try. At x equals to 1, y is equal to 2. So you've got 2 is equal to the cube root of, what's that going to be? 3 times 1 squared, so this is 3. Cube both sides to solve this guy. So we're going to get 8 is equal to 3 plus k. Oh, that's not too bad actually. K is equal to 5.
Yeah, that's pretty good.
I unintentionally created a nice number set, eh? So yeah. So that is our particular solution that goes through this point here. Right, so therefore, y is equal to the cube root of 3x squared plus 5. And again, we could sketch that visually and see what that looks like, right? But basically, this is the one curve that is a solution to this differential equation, but also passes through this point here, 1, 2, okay?